the only things we change are size and position and the temporary variables. So here we change position, here we change size. Yeah, this is pretty classic. It is exactly like the position is simply, the velocity is simply the wrong one. Okay. Let me try this and see what happens. I want to make sure that this is the one. No. Okay, so we should be going. Should be hitting this one, right? Our bottom edge gets hit. So we actually want it going up. But I'm going to change things, and just in case, I'll put 11s. So I want to test that this actually has an effect. Please just, I don't get this dynamic filter. Noise gate, please open up. I did too many short sounds. Lots of P's. P's really stop the sound.
Please open up. Please open up.
Yeah, that also left the bottom edge.
Please.
So it didn't matter that I flipped the sign. It's almost like it doesn't care what the sign is. And that's blowing my mind. Okay, let's put a negative here. Well, let's go back to 1. So that doesn't do the right thing, and this doesn't do the right thing. It should be positive, but I'm just seeing what the changes are. Okay, you can do the right thing now. Yeah, still the bottom edge. Still the bottom edge. Doesn't matter positive or negative. Hey, wait a minute. That was calling filter cube overlap top. Because that went at the 11 rate. Weird. Okay, let's try that. I wonder if the result thing is not standard. No, it can't be. Otherwise, half of these would have been correct. Okay, so if it goes fast, it's top, and it should be top. Yeah, I did the right thing. I did the right thing finally. I did the right thing. I've run the code like this before though, just with 1 instead of 10. I can't guess. Hey! So there's a long one. Watch this. It's gonna work. so that one worked. So for some reason 11 works, but 1 doesn't work. That's what I've come to conclude. Let's try a 1, which is a nice slow rate. And hello, please work.
Please work.
Yeah, it doesn't work for low values. It works for high values. So that means that something about our scaling by half and all that is wrong. Oh, I really want to get this done so I can do cool effects. Okay, this is not a hard problem. I don't know why we can't fix this. And of course, I'm not blaming you, dear viewer, should you happen to exist. Filter Vex scale dp 0.5 dp. Let's go back to our thingamabob. So we don't want to move, and now we don't have this blue guy anymore, so that's good. We don't really have this white guy anymore, so it looks like it depends on our speed, and our speed should only affect this distance here, this guy. It's even much smaller. Yeah, this distance here, from the green to the red. So let's see again. Green is the original one. To get it to where the white block is, first, actually, size. This is hard. This is hard. Yeah. Other way to do it is from the green one, you reduce the size first. So that'll put you half of that, so this much on both sides. So it'll go half of that, and half of that, like that. And this would be, if you reduce size first, you would get this. No. You'd get that. Yeah. And the position would still be at the green dot, centered around the green dot. And how much would you have to move it to get it to the white dot? Well, exactly this blue half. Yeah, so it's the same, right? I don't see what the problem is. This is what we're doing. Wonder if the error is somehow in the compounding and the time step being small. Inval time step dp. Yes, you need to do this. There's no getting around this. The time step, if you reduce size first, you would get this. The time step, if you reduce size first, you would get this. The time step, if you reduce size first, you would get this. The time step, if you reduce size first, you would get this. The time step, if you reduce size first, you would get this. The time step, if you reduce size first, you would get this. The time step, if you reduce size first, you would get this. The time step, if you reduce size first, you would get this. The time step, if you reduce size first, you would get this. The time step, if you reduce size first, you would get this. The time step, if you reduce size first, you would get this. The time step, if you reduce size first, you would get this. The time step, if you reduce size first, you would get this. The time step, if you reduce size first, you would get this. The time step, if you reduce size first, you would get this. The time step, if you reduce size first, you would get this. The time step, if you reduce size first, you would get this. The time step, if you reduce size first, is not in, well, is in seconds. It's a float value. Okay, then we take half of that integral, and then we add it. Yeah, it's almost like a rounding error or something. I don't see what's wrong with this. I need help. I think I need help. I can't figure it out. DS. It's all like turning spaghetti in my brain. Shoot. So why does it work when it's going fast? That doesn't make sense to me. When it's going fast, it works completely fine. I mean, we're not doing any conversion to int or anything. We shouldn't be losing anything. Alright, I'm going to take out the size component for now. So it should just move up forever. Let's verify that that works. Sleepy. So it should collide and just continue to move up forever. But it's moving down. And that's because our stuff is not... Yeah, so for some reason it thinks the bottom is the top. I don't know why. Yeah, and that would throw us off right now if we were to flip that around. Okay, so I'm going to flip these around. So it doesn't matter if it's not bottom or the top. Now the result should be flipped. And that should continue upwards. Hey, why don't you work? Still moving back down. Isn't that weird? Regardless of what I put in here. Right? I mean, I flipped the signs. I don't get it. I flipped the signs and it moves in the same direction.